Welcome back. And what we're going to be discussing today is going to be on Python basic data structures. Basic Python data structures allows us to organize our data in a much more efficient way. And through this video, we're going to be discussing four basic data structures in Python, namely lists, tuples, sets, and dictionaries. So let's get into it. Okay, so the first data structure that we are going to be discussing is going to be lists. And think of a list as a piece of paper where you write your shopping list in. So you have the ability to remove, add, and write whatever you want in this piece of paper. So similarly, in Python, a list is a data object that has the ability to store different types of data. So we call it heterogeneous. On top of that, it is mutable, thus you have the ability to add or remove any item from this particular list. It's zero index, which means the first element is going to be represented by zero, and you can have duplicate values in it. Okay, so let's try to understand exactly what it is by first understanding how to define a list. So in order to define a list in Python, you have two ways. Either you can define it using the square brackets like this, or else you can use the list inbuilt command, and within this you can write the aspects that you want. So both of this are ways of defining a list in Python. So let's say that I want to define a list called my list, and within this I'm going to be storing these three elements. So this is the first element is banana, the second element is cherry, the third element is apple. Why I said that it was zero index is this particular element, which is the first element within the list, it is not actually represented by the index 1 but rather by the index 0. So for an example, if I was to print the 0th index and the first index, you see that, sorry, I had to run this. If you run this, you see that the 0 index is actually representing banana, whereas the first index is actually representing cherry. So always keep in mind when you're trying to call a value from a Python list, it's 0 index, so the first element is actually represented by 0, right? Got it. Next, the Python list is ordered in the sense, if you want to, let's say, add a element such as orange into this initial list, you can use the inbuilt append function, and then within this brackets you can specify the value that you want to append. And why it is referred to as ordered is because when you append it, this particular element that you added right now is going to be added to the very end. Okay, it's not going to be added to the very as the first element, but to the very end. So if we were to run this, you see that my list has been modified with the orange element, but it has been added to the very end. So that is why we call it as ordered, right? So let's say I want to add again another orange into this particular list. So since Python list allows you to have duplicates, when you run this, it will add another element to the far end, which is orange. And as you can see, you can have duplicates in these lists. But imagine now you want to add a particular element to this list to a specific location, okay, not to the very end. So if you use the append function, you'll be adding that element to the very end of the list. But if you want to add it to a specific location, you can use the insert inbuilt function, and within this, the first argument that you have to send is going to be the index at which you want to add this particular element, and it should be then followed by the argument which is going to be the element that you want to add. So let's say in this situation I want to add strawberry to this particular list, and it should be on as this, it should be the second element or in the first index of that particular list. So if I was to initially print the list and then insert it to the position where it is represented by index number 1, and if we were to print it, you'll see the difference. So initially we had this particular list, And since we inserted strawberry into the first index, you realize that it has been added between banana and cherry. So that is basically how you insert a specific element to a specific location in a list instead of using the append function. Okay. The other thing is this is mutable in the sense a Python list is something that you can change. So similar to a shopping list, you have the ability to cut things, you have the ability to write duplicates as well as add or remove things, right? So similarly, a Python list can be changed at any point. So, for an example, if you look at this, the first element is banana, and imagine I want to change it to something. Okay, I want to change it to the element called something. So, how you do that is you would say my list, and within square brackets, you will refer the specific index where the element that you want to change is available, and then you will equal it to the element that you want to or the item that you want it to be changed to. If you run this, you see that the first element, which was banana initially, was changed to something. Next, imagine that we want to add, imagine that we want to find out exactly where the element called apple exists. Okay, we want to find out the index where the element within this list called apple exists. So for that particular purpose, you can use the in-bay function called index, and then within this bracket, you can state the element that you want to find. And if you run this, you see that in this particular my list, the third element, the third index, which means the fourth element, is apple. Okay, so if you count 0, 1, 2, 3, that is apple. Okay, so imagine if for some reason that you um, refer to something that is not available within the list, then it will throw a value error saying, look, this particular element is not within this list when you use the inbuilt index function. Now if we were to, let's say for an example, right, we have two oranges, right? We have two oranges. So if I was to find the orange, what do you think will be the output here? So if I run this, you see that it is actually 4. So it's actually this particular imb function is returning first occurrence of that particular element, the index of the first occurrence of that particular element. Okay, cool. Now how do we remove stuff? Now we added stuff, we changed stuff. Now we want to remove stuff. So if you want to remove the last element, since this is an ordered data object, you can use the pop function. So if you can state mylist.pop, and that will remove the last element. So if we were to look at the print of mylist at its initial case, so initially we had two oranges. Now since we have used the pop function, it has removed the last element. Imagine now, now we have added different values, right? And I want to be very specific. If I use the pop without any sort of an argument, it will be removing the element at the very end. But if I want to be very specific and remove a specific element within a specific index, then what you need to do is you need to just specify mylist.pop, and within this particular bracket you can specify the index of the element that you want to remove. And if you run this, you'll see that initially we had something strawberry, cherry, and all sort of things, and the first element was represented by strawberry. Now it has been removed from this particular list. Okay, a good way to, like, let's say, how do we use these, the pop function and the index function together? Simply, what you can do is you can initially find, what we're going to be doing is we're going to be initially finding where this particular apple index exists. Okay, and then we are going to be storing it to the fruit index element. variable, and then we're going to use that, and then we're going to pop the or we're going to be removing that particular element from the list. So here, as you can see, we have apple, which is on 0 1 2, the second element, and then we are going to be popping that so that we can remove that from the list. So see, we have removed apple. So that's a way of using the index and the pop function together in order for us to do changes within a list. Now, I mean, instead of going to the hassle of doing all of this, you also have the inbuilt function called remove, which allows you to remove the specific element directly by specifying what that element is and what you want to remove. So here, if we were to run this, you see that initially my list contained cherry, but now since we are use the remove embed function, it has removed that from the list. Okay, so now we are left with a very small list. So I'm going to rewrite the list, and this is going to contain banana, strawberry, cherry, apple, and orange. So next we are going to go into sorting. So let's say, for an example, I want to sort this particular list in the ascending order or in the alphabetical order. For that particular purpose, I can use the sort inbuilt function. So if I was to run this, I mean, my list is now not in a specific order, but if I run this now, it has been ordered. Okay. Then if you want to kind of reverse the order, in the sense, if you want to sort it in the other way around, from descending or from Z to A, then you can use the reverse equals true within the sort embed function, and which is here it is set to false by default, but if you change it to true, it will reverse. But also understand, if I was to, like, use this reverse sort, you can also use this embed function called dot reverse, which will also reverse the initial uh, list into the other into, if it was descending, it will be becoming ascending order. So if you run this again, it will change to the other one, to descending, and if you run this again, then it will change back to ascending. So reverse is basically changing the order of the particular list. And the final thing to learn about list is how do we clear a list. Basically, you can use the inbuilt dot clear function. And when you run this, the list becomes empty and all the aspects within the list is going to be removed. So the next aspect is certain sample operations that exist in lists. So let's say that I want to remove the duplicates that exist within a list. So there's a specific data structure called a set, which will not allow any duplicates. So if I was to remove the duplicates that exist within a specific list, what I have to do is I need to convert this particular list into a set and then back into a list. Then when we convert it to a set, when we convert the list into a set, the duplicate values will be removed. And then when we reconvert it back to a list, it will become a list with no duplicates. So let's say here we have this list defined called isin list, which has two elements that have been duplicated. So this one and this one has been duplicated. So what we do here is, initially we are going to be printing it, and then we are going to be converting this list into a set, and then we are going to reconvert this list into the set into a list. So that is what is happening here. So I'm going to print all of it. So initially we had this specific list, these two elements are duplicated, and then we convert it into a list, and as you can see, it's a curly bracket. No, that is not what we need it as a list, so we have to reconvert it back to a list. So that is how you remove duplicates within a list. Another one that is interesting to learn is how do we append or how do we connect two sets of lists. The way that you do it is very easy. Basically, you have to define two lists. So here we have defined two lists, and you can just use the add operator, and this will automatically add the two lists together or append the elements within these two lists together. Okay, so that is how you connect two lists together. Next is indexing and slicing. So let's say now we talked about the fact that lists are zero indexed, which means the first element is going to be represented by zero. So if I want to slice this list, so we have this list here which contains 1, 2, 3, 4, 5 elements. If I want to just select the elements from 20 to 30, in the sense only these two elements, that is basically what we call as slicing a list. Simply like if you have a cake, if you take a piece of it, you have to slice it. So similarly, if I was to slice the the uh, second element and the third element, how you have to define it is you will have, say, my list, and within these square brackets, initial index that you're going to be setting is the index that this slicing is going to begin. And then you're going to say, now this particular element index is actually 2, right? But we are going to be saying 3 here, right? So we are going to say 1 double dot 1 from 1 double dot to 3, which means we're going to be slicing from index 1 up until 3, excluding 3. That is how you define a slicing in a list. So you, if I was to take these two elements, you will have to specify it as 1 from 1 to 3, excluding 3. So always keep that in mind. That's how you define and slice a list. So now you get these two values that you wanted initially. So similarly, let's say that I want to slice up until this particular element. So if I was to count, or if I was to count the index, it would be 0, 1, 2, 3, right? So how you would slice it is you're going to say from 1 to 4, excluding 4. So then you will get these three. Got it? Now, let's say that I want to slice up until the fourth index, but excluding fourth and all the elements prior to it. So then you don't need to say 0 here. You can say double dot and 4, and that will automatically slice the values from the initial element. You don't need to state 0 here. It will automatically um, Python will automatically detect and say, okay, you want me to slice from the beginning until the fourth index, excluding the fourth index. Let's say that I want to slice from the second index, which is this, um, and the rest of it. So towards the end, from 2 to the end. How you define that is 2 double dot, and you don't need to specify the last element. You can just say 2 double dot, and then Python will automatically understand, okay, you want me to slice from the second element to till the end. And that's how you slice an index in Python when it comes to lists. So the next data structure that we are going to be learning is going to be dictionaries. So think of a dictionary as a shopping list, but it also contains certain additional information such as nutritional value of that particular food that you're going to be buying. Okay, so a dictionary is basically a data structure where you use key value pairs. So you have a key, and for each of these keys there's going to be a value. An important thing to notice is, or to understand, is that the key should always be unique. Okay, the keys cannot be duplicated, and but the values can be duplicated. So you have a key, and then you can have a value, and this value can be a string, a number, I mean an integer, a float, even a list, or any other data structure as well. Okay, so let's try to get into it by first initially defining a dictionary, and then eventually understanding what exactly is going on. So how you define a dictionary is either you can use the curly brackets, or else you can use the dict inbuilt function. So this will basically tell Python, look, this is going to be a dictionary. Now let's say if I was to store specific information surrounding a particular person, and if I mean this particular information that I'm trying to store is going to be a profile of that person. So we're going to be storing the name, the age, the telephone number, and the address. Okay. So if I was to put this into a list like this is going to be very inconvenient, because then if I was to call the specific element, let's say I want to take the name, then I'll have to state that state the index of that particular element, right? But if it is a very large list, it's very difficult for someone to keep in mind which index that particular information is stored in. So that's going to be very inconvenient. So a solution for that is to store certain things like that in a dictionary where you have a key and a value, and these key value pairs will make up the entire dictionary. So let's say for an example, I want to store the name, and what I will do is I will say I will define the key called name, and with these double dots I will say the value, which is going to be Python. So this is the key, the one on the left is the key, and the one on the right is the value. And then I will put a comma. So this is one element, and the next element where I will define another key called age, and then I will state the value, and then another element which will be call details, where you will have the home number and the work number. So this is a dictionary within a dictionary. That is also possible. So the value, as I said, can be a string like this, can be a integer, a float, or even another data structure, or even a dictionary as well. So here what is happening is I'm defining a value where the value is a dictionary, and within these value you have two key value pairs. So let's try to see how we can call them. Okay, so now I have defined this particular dictionary. Now let's say I want to call and I want to get the name of this profile. So if I was to get the name, I just have to do what I have to do is I would have to state the dictionary name, and within square brackets I need to specify the key that I want to grab the data from. So here I want to grab the data from the name, and when you run it, it will print, it will give me that particular value that is attached to that particular key. So let's say that I want to get the call details. And now you will see that the call details is actually coming in a dictionary itself. So what you need to do is initially you call the call details, and then within this, if I want to get the home one, home numbers, what I will do is I will say call details, and within a square bracket I will say home, and then that will give you the home number. So that is how you basically get elements or call elements within a dictionary. You just have to state the key, and if there's a dictionary within a dictionary, you can initially call the key of that particular dictionary, and then you can then call the key of the element that you want to fetch, the within element that you want to fetch inside that particular dictionary. Okay, so how do we change a value? Now you need to understand how to change a value, right? So let's say for an example, I want to not just change, but I want to add a value. So if I want to add a new element called gender, what I would do is I would say profile, and then I will specify look gender as a key, and then I'm going to equal it to male. And as you can see, a new element has been added to this profile, to this profile uh, dictionary. So let's say that I want to change the value of the existing key. So I call profile name, and I want to change it to Python 3. Okay, if I do this and if I print profile, you will see that it has been changed from Python to Python 3. So that's how you changed an element in a dictionary. So basically state the key, and then you can equal it to the value that you want to change it to. Now, I told you about the fact that these are key value pairs. Each element is a key value pair. If you want to get all the values, what you do is profile.values, and it will give you all the values that exist within that particular dictionary. If you want to get the keys, you can use dot keys. which will give you all the keys that is available for you to use. And if I want to get um, the keys and the values as tuples for the purpose of iterating, for example, you can do this, which will basically give you the key value pairs as a tuple. So a useful case of where you would want to use this is, since this is coming as a tuple, you can say I comma j. So I will represent, okay, I'm going to put here a key, and this is going to be value for in let's say profile dot items. And if I was to iterate through this, we learned about loops. And let's say I want to print the key, and then I'm going to print the value. And that is the whole purpose of this loop. You will see the key has been printed, and then the value, and then the key, and so forth. So let's say, let's add a little bit of a string to this so that we understand this is the key and that is the value. So let's do this, and this is the value. Um, and if we run this, you see this is the key, this is the value, and so forth. So basically, it's iterating over the keys and the values when we use the in-bay function items, because it's going to return this sort of a iterative object, which where each element is represented by a tuple, where the first element of the tuple is going to be the key, and the second element of the tuple is going to be the value. So the next data structure that we are going to be learning is tuples. Now, lists are basically like a piece of paper where you write a shopping list. You have the ability to change it. There is you can add duplicates. You have the ability to add different items into it. A dictionary is basically a shopping list that has nutritional aspects. Basically, for each key, you have a value as well. A tuple is like a laminated list. Okay, a laminated shopping list. Basically, when you create a tuple, you can't change it. So always understand the word that we are looking for here is immutable. So the tuple is immutable, simply which simply means that it's a laminated shopping list, which means you can't change it once you create it. So you can't change the elements within it once you create it. Okay, so let's understand how you define a tuple. You can either use the normal brackets to define it, or you can use this inbuilt function called tuple to define a tuple. Okay, so let's say if we print the type of it, you see that it is a tuple. So this is basically a tuple which I have defined. And if I print this, you will see this being printed where the brackets are normal brackets. And if you go above, you see that dictionaries are actually having curly brackets, but the difference is that it has key value pairs. And if you look at the lists usually have square brackets. So that's how you identify which type of data structure that we are dealing with. So if I was to, it's very similar to a list. The only difference that you find here is um, the that you can't change an element. So let's say that I want to fetch the first element. It's zero indexed. You will specify the tuple's name, and then you will tell the element. And if I was to change the first element, which is something that we were able to do in a tuple, if you try to, like, use the index and then you equate it to something else, you see that tuples does not support item assignment, which means it is not changeable. Okay, but how do we change it? So imagine you have created this specific tuple, and now you have to change it. You have to change that particular item that is within it, because you have done some sort of a mistake. So how you do it is that you will have to come up with a workaround um, to kind of counter the fact that you can't change it. So what you do is you will initially convert the tuple into a list, and then you will change whatever that you want, and then reconvert it back to a tuple. So let's say for an example, what I'm doing here is I'm going to be converting this particular tuple into a list. So now if you print the type, it's a list. then I'm going to change the element, let's say the first element, into something which is what I wanted to do initially as well. And it is basically a simple list operation here. And now that particular list contains the value of the first element is going to be something, and then you reconvert it back to a tuple. So now the sample IC, which is the tuple that we defined, now has the first element as something. So that's a workaround for the fact that you can't change a tuple once you create it. So what you do is you initially convert it into a list, and then back you change whatever that you want, do the list operations, and then come back and change it back to a tuple. The final thing is you need to also understand how to add elements to a tuple. So let's say for an example that I want to add an element called last element, and how you need to define it is by the use of you have the normal parenthesis. You will specify the the element that you want to add, and then you will have to add a comma and an empty space. If not, Python will not detect this as a tuple. Okay, so after you do that, then it's basically using the add operator, you can add the two tuples together. So if I run this, you see that initially we had this. Now we have added an element to the very end of this particular tuple. So let's say now, why did I say that this? Let's try to see the difference. So if I go here and if I print, if I try to detect the type of this, right? Let's take the type of this. So it says it's a tuple, right? But what if I say now this is a tuple because I have added this comma. What if I miss this comma? What happens here? It's going to be stating as a string. So always remember, if I was to define a tuple, you need to make sure that this comma is there, or you have two elements. If you're only specifying one element, you need to still add this. If not, it's going to be considering this particular element as not a tuple, but rather whatever the type of data that is inside this particular brackets. Okay, so always keep that in mind. So the final data structure that we are going to be learning is going to be sets. So sets are basically shopping lists with no duplicates whatsoever. You can add new items as well into a into a set. So how you define it is by the use of set embed function, or you can use the curly brackets like this. So since this does not have key value pairs and just values, this is going to be identified as a set. So if I was to add a key value pair, then it will become a dictionary, right? So the only cool thing about a set is it will not allow you to have duplicates. So as you can see, this element and this element are duplicates within this set, and once you run this and print it, Python will automatically remove the duplicate. Okay, if I was to add an item to a list, you can use the dot add function into a set. You can use the dot add function and then specify that particular element. So it has been added. It will be added. It's not an ordered. This particular data structure is not ordered, so you can't actually you can't predict where exactly this will be, the new element will be added to. And if you were to, like, let's say that you want to uh, update in the sense you want to add this particular element, you can add it like this, which will add it to whatever the location that you want. So make sure that you put it, let's say that you can use the add function, or you can also use the update one. So if you're using the update one, make sure that you add square brackets. If you don't add square brackets, what this particular update function will consider this to be individual elements, and then as you can see, it will only add the non-duplicated value to this particular set. So here it will take each of these as elements within a specific data structure, and here it has removed the two and remove the duplicate twos, and the three has been added, which are the only two items that is not duplicated into the set. Okay, so that is basically uh, a set which is a shopping list which does not have any duplicates, and it is an unordered data structure. Right. So the final thing that we're going to be learning from this particular video is going to be on list comprehension. So list comprehension is a concise and a much more efficient way of creating lists out of loops that iterates over some sort of a sequence. So let's break it down into an example so that we understand exactly what we are trying to understand. Okay, the final part that we're going to be learning out of this video is going to be on list comprehension. So list comprehension is an efficient and a concise way of creating lists out of loops that iterate over a sequence. So let's put it into an example so that we understand how it becomes efficient and concise. So let's say for an example that I want to create a list of square numbers, and initially I'm going to define this particular list here. Then I'm going to iterate over this particular range, and for each element that I iterate over, I'm going to square it and then going to append it into this particular list. So I've imported time, and I'm going to check, identify the time that it takes to run this entire code. Okay, so let's run this. And as you can see, it took me around 3 seconds to run this. Now, a much more efficient and a much more concise way of doing this is to use list comprehension. So let's try to understand how to define this. So we know for a fact that we want to start a list, right? So because of it, initial part of it is we are going to be saying, okay, look, this is going to be a list. So that is why we are adding the square brackets. Then we are going to be defining the range, the looping criteria. So here we have defined the looping criteria. And in front of this looping criteria, we are going to be adding how the element needs to be stored inside this particular list. So if the element was just going to be stored, then you can just say X. But here we want to square it. So that is why I have said, look, X should be squared and that should be added as an element to this particular list. So this is basically writing all of these 3 lines in a single line. So let's try to run this and see if this is efficient as well, because we obviously know this is now concise. So once you run it, you'll see that it only took us 2 seconds. So basically, if you're trying to create massive lists like this, instead of writing all 3 lines like this, use list comprehension, because it's going to be both concise, going to make your code more concise, as well as it's going to be a lot more efficient. Okay, so try to understand a little bit more about list comprehension, and there is a video within our playlists, within our channel where we talk about list comprehension in much more detail. But all in all, just remember, list comprehension is a much more efficient and a concise way of creating lists which are created out of looping over a sequence. Okay, so we learned about simple data structures in Python through this video. We talked about lists, tuples, dictionaries, and sets. We talked about their operations, how to add, remove, how to duplicate, how to remove duplicates, and all sort of things. So do follow along the rest of the videos as well. And we'll see you in the next episode. Thank you.